Now we're at lesson 17C, numbers never lie. Just as we are all consumers in the marketplace and need to be careful as we spend money and make choices, we need to be careful when consuming information. We need to look critically at data and graphs. It does not mean that we never trust anyone or any graph, but it does mean that we should be cautious. And one of the things I'd say in class is a healthy paranoia. Just challenge, think, consider, question, be professional. Question number 1. Should you always believe the numbers? That is not a straight line. Do you think the data can lie? Give some examples either from your life or from earlier in this course or other courses. This is definitely something you need to write down that's personal to you, whether it's about graphs or comments or things that we've talked about. Write down something, and then let's go look at the objectives. So in this lesson, we're going to understand that the presentation of data, either graphically or in writing, may be manipulated to tell a particular certain slanted story. It is essential that you and I critically and accurately evaluate graphs and data, not even what you may not see on the page, like who sponsored the study, what's going on behind the scenes, especially when presented in support of an argument. We're going to be trying to find distortions or biases in graphical representations of this data. We're going to try to identify misleading aspects of graphs and mathematical errors in the graphs. And then finally, we're going to write an accurate critical analysis of the data. We'll summarize our criticisms of the data and the graphs, and then we'll identify potentially misleading information. In this question, we will look at federal hourly minimum wage from several different perspectives. But you need to spend time in thought and thoughtful responses on all of these. It's going to be great for you to hit pause before each one, or right now just go ahead and tackle all of question number 2. But do spend some time thinking about your responses. Part A, has the federal minimum hourly wage always increased, or has it ever decreased? And what is the current federal minimum wage? Some of the things you might want to answer is that the minimum wage has either increased or stayed constant since it was instituted. As of December 2014, the federal minimum wage was $7.25 an hour. It'd be good to Google what's going on for 2018. Before we begin or continue with question 2, part B, I would like to show you this information just for you to have, to jot down, take a screenshot of, but there are some ways in which data and visual displays can be distorted. There are lots of ways, but this is kind of a nice summary. Some of the ways that visual displays can be presented in misleading or distorted ways include A, skewing the data or skewing the graphs to slant the data. We could also make inappropriate comparisons, like if we don't convert the money to constant dollars. We could also see or have a poor use of pie charts. And then we could present inappropriate correlations and causations. Understanding these ideas and having others rolling around in your brain, these and this will help you to ask critical questions about visual displays. So now go look at part B. Some other things we've talked about on graphs are that before we even try to answer, we look at different pieces of the graph, we look at it critically as it says earlier, and then we just ask different questions. What if, what do I not see, what do I do see? And so it says the graph below shows the historical increases historical increases, federal minimum wage using the data from the Department of Labor, and there's even a nice little superscript that tells us where this comes from. In your group, identify at least 2 ways that this graph may be used or may be distorting the data. You don't have a graph, maybe you are studying with someone or somebody in the room, get them to look at it with you. It is historic minimum wage in the United States. This over here looks pretty good. It's going up by $2. And so let's check out the dates. 38, 39. Uh-oh. What happened to 40, 41, 42? And then it jumps to 50, 56. It could be that someone has selected the dates they wanted us to look at. It is not consistent on the x-axis. What else could be going on? The graph shows data for the years in which the minimum wage was raised, but doesn't show any of the other years. So it gives a false sense that wages have increased consistently, even though they've been stagnant, didn't go anywhere, over several long periods of time. The column graphs can give an impression of a greater increase. For example, by just using this kind of a picture, the area and column of 2009 can look so much larger than what was going on in 1938, and it makes it look more significant. And the wages, these wages that they're reporting, like right here, whatever that lines up to, whatever it lines up to over in the money, these are given in real dollars. Like the 1938 wages are given in $1938, and they haven't been adjusted for inflation. And that can skew the actual increases. So it looks like a few things are going not well for this graph. Let's see if it gets better on part C. So looking at part C, this graph shows the federal minimum wage for all the years between 38 and 2009. Do you think this is an appropriate way to show the data? So I would still be critical. Are they messing with the numbers over here? Are they, wait a minute. It is all the years, 38, 39, 40, 41. Okay. Looks like it is all the years up to 2009. Then it goes on to 2013. So is this a guess in the data? What's going on here? It is historical. Are we still okay with this? And does it mention that it has been adjusted for inflation? Or again, are these real dollars? Write down some thoughts and stuff you might want to consider saying. The data does show the years in which the minimum wage was raised. Oops, sorry. Looking at this, the graph is better than the previous graph because it does show clearly that the minimum wage has stagnated several times. Here, here, and in fact, since 2009, here, so no question mark. However, it is still not adjusted for inflation. Nope, they didn't adjust. So it's not clear whether the minimum wage has kept up with inflation. What's the value of this as compared to the value of this? So let's try again. Go on to part D, make some comments. So looking at part D, it shows again that this is the minimum wage data where the dollar values, the dollar values are adjusted for inflation, and everything here is represented in 2014 dollars. But then there are more questions. Why would somebody use this graph? And what argument does this make about the minimum wage? So let's still analyze. It's still being consistent, 0, 2, 4. This is where it is represented in 2014 dollars. It is going by decades, so we're assuming they're hitting all of the years in between. Do you like this one better? Do you not like this one better? And then answer, why would someone use this graph? And is it actually a better argument, or what kind of argument does it make? And then look at points on this chart. Like look right here. Where is this and when is this? This is like $11. It's right here, maybe 68 or 69. What's this point here? This is somewhere around 1938. That's that one and this one. Those are the lowest points on our graph. And then about-ish right here-ish is where we are right now. And in comparison, we're not the highest, but we're not the lowest. So why would someone use this graph? The graph shows that in 2014 dollars, the minimum wage has both increased and decreased at various times. By comparing all of the hourly wage values to a common standard, we can see more clearly that the minimum wage would increase and then over time would decrease. It reached a high in 1968. It reached a high in 1968 when it was equivalent to almost $11 per hour today. The current minimum wage of, and that's mentioned for whatever it said a while ago, like 2014, is low compared to some of the values in the past, but then it's high compared to some of the other values in the past. Write down some thoughts. Let's move on to question 3. Before we go into question 3, I want to re-look at this where we can have parts of skewing to slant the data, making inappropriate comparisons, like not converting money, sorry about that, to constant dollars, poor use of pie charts, and then presenting inappropriate correlations and causations. Now go ahead and look at questions 3 and 4. Look at them, write down some comments, and I'll catch up with you in a second. Question number 3, Fox Chicago News story, broadcast 2009, leading Republican candidates, 2012 presidential race. The new Opinion Dynamics poll shows that Sarah Palin on top when it comes to landing the nomination. She's at 70%, Mike Huckabee at 63%, and Mitt Romney at 60%. And then they used a pie chart. What's the problem? And how should it have been graphed to be a bit more accurate? Well, one thing we can do is to take all of the percentages and add them up, because one whole pie should add up to one whole 100%. So if we have 12 and 7, we have a whole 193%. So a pie chart is not the best graphical display for this data. And it's using the pie chart is not appropriate. The poll that was taken most likely allowed respondents to name more than one candidate, and so something like a column chart would have been a better choice of data, better choice of representation for these data. Let's talk a little bit more about pie charts. Pie charts can be poor representations of data for other reasons. They ask you to go access strange facts about cats. I'm going to display that in just a second. Scroll down until you see the graphic illustrating the cat's sleep, that cat's sleep for 16 to 18 hours per day. Let's see if I've got it over here. Oh, there it is. So here is data about cats. And then right here, they're showing that cats sleep 16 to 18 hours a day. The question for this is, what's wrong? Make a quick sketch of the pie charts, and then what's wrong with them? Well, a pie chart is supposed to represent a whole, so the wedges are a little bit confusing. And do the smaller the wedges represent smaller amounts of time that the cats sleep? And if so, it's not clear what the large wedge represents. And 16 hours is 2/3 of a day, and this wedge looks not like 2/3. It looks like 15%. And maybe these wedges are supposed to be clocks, but their sizes just do not make sense. So what's something that we could do to make this look better? Sketch a graph that more clearly represents the amount of time that cats sleep. So it's 16 to 18 hours. So out of a whole 24-hour day, I'm going to take 16 and divide it by 24, and this would be about 67% of the day, and 18 divided by 24 is about 75% of the day. If we hit the middle and do 17, and that's about 71% of the day. Either way we go, if we're looking at a pie chart, oh goodness, 75% would be about right here. And so one of these is 75, then a little bit less and a little bit less. So let's draw this a little bit, um, oh wait, sorry. That would be 25%. So 75%, we'll have to draw a little bit more. So if it's around 70%, 71%, 67, we could even just call this 71%. And this is how much the cats sleep. And then if that's how much they sleep, then the other part would mean they're awake about 29% of the time. This would be a much better representation than what they displayed in their information. So make sure you have hit pause and that you've looked at question 5, all of its parts, and made some comments, and then realized I don't think everybody intends to skew the data. I think sometimes they see something that makes sense and it looks great to them, and then when somebody else sees it, it's like, this is just distorting what you think they're trying to say. And so it does say, look at the following graphs and identify at least one item that seems to be misleading or distorting the data. Here's what's called the SESI survey. You've got data, how much support does your college provide? And it's kind of odd with these spacings and 3Ds and what's going on. And so the three-dimensional aspect kind of distorts the wedges. We're kind of seeing this volume here and not so much the circle piece. And so it looks like, I don't know, it looks like more than 50% when it may not. Anyway, it just looks kind of weird. And the smallest wedge that's representing very little, it looks really, really small. Presenting the graph this way minimizes the negative, those that would reflect poorly on the school, and it emphasizes the positive. So maybe this was intentional, maybe not, but it does seem like a better choice of display could have presented the information more clearly and accurately. This one's kind of funny to me. It says the text below is from an actual email message. Do you think it's real, and what's suspicious? So learning a language in 10 days, that would be suspicious right there. Scientific discovery reveals how you can learn a language in 10 days using this sneaky linguistic secret. This method was recommended by Forbes and it was purchased by the FBI. Shocking results. Click here for the full story. Well, this ad is an example of using a number to make a claim sound true. It's unrealistic that somebody could really learn a language in 10 days, and it's also strange that we might get an unsolicited email offering to reveal the secrets of their program. Why would somebody send that? I would be suspicious, and it's likely that the link is going to lead to a website which they're going to try to either sell you something or it's going to download a virus to your computer. Beware, don't be tempted to click on this, move on. Finally, we're looking at Part C that says data shown from the United States Bureau of Labor Statistics and the Department of Justice Statistics show a strong correlation. Okay, that's nice to have a strong correlation between fresh fruit consumption and household burglaries. Clearly, the old saying, an apple a day keeps the doctor away, should be updated to an apple a day keeps the burglars away. Okay, so then you're looking here, we have our y-intercept, we have information, we have a correlation. Okay, we can look at the graph, we can look at what's going on our axes, but bottom line, remember correlation is not causation, and there can be other confounding variables. We cannot assume that there is a causal relationship. And also there are two completely unrelated variables. The spreadsheet software found a strong correlation. The R squared. The R squared is 0.825. The R, when you take the square root of that, is 0.908. Because for various reasons, the amount spent on fresh fruit increased while the number of burglaries decreased. Another problem is that we do not know what time period is presented. So although these axes look good, and this one looks good, although it's not starting at 0, we don't know the time period. You don't know the years, over how much time. Is this graph showing 1 year and the fruit purchases and burglaries cycling up and down? The data do present years from 94 to 2003. Anyway, just remember, correlation does not imply causation. And remember that this lesson is now over. We're done with 17C. Go look at your syllabus and see if there are more lessons to do. If so, keep going. If not, do that happy dance, and I'll see you the next week.